Space, an infinite canvas stretching beyond our wildest imagination. But what we see today, the quiet vastness of the cosmos, is a snapshot of a universe in motion. A universe that's been expanding since the very beginning of time. In fact, the universe has been stretching outward ever since that pivotal moment known as the Big Bang, more than 13.8 billion years ago. The idea that space itself is stretching and that galaxies are moving apart as a result is so profound that it reshapes everything we know about reality itself. It challenges our understanding of time, of matter, and of the future. When we look at the cosmos, we're not just looking at a distant collection of stars. We're seeing the past, a history of expansion written in light and galaxies, frozen in space-time. But that history is still unfolding, in a dance that continues every moment. The universe is not static. It is alive, changing, growing, and we are watching its story evolve, even as we try to piece together what it all means. It all begins with a singularity, a point of infinite density where time and space as we know them don't exist. In the blink of an eye, this singularity exploded in what we now call the Big Bang. It wasn't an explosion in space, but an explosion of space. The universe began as an infinitesimally small, incredibly hot, and dense point. In an instant, space itself began to expand at an unimaginable rate, a process that we call inflation. This rapid expansion stretched the universe to many times its size in a fraction of a second. In those first moments, all of space was filled with energy, a primordial soup of particles and forces. Matter as we know it didn't yet exist. But as the universe cooled, quarks, electrons, and other particles began to form, eventually creating atoms, the building blocks of stars, galaxies, and everything we observe today. And yet, the expansion didn't stop. For over 13 billion years, the universe has continued to stretch, space expanding and carrying galaxies farther and farther apart. Imagine, for a moment, that you were watching the universe grow, not over millions of years, but over the span of a single day. In the first few hours, everything would have been incredibly compact and hot, filled with energy. By midday, galaxies would begin to form, stars igniting across the vast sky. But by the evening, the universe would be unrecognizable. Galaxies would be moving away from each other, and the sky would be darkening as light stretched and faded. This idea that galaxies are moving away from each other as space itself expands is at the core of our understanding of the universe. In the 1920s, the astronomer Edwin Hubble made a groundbreaking discovery. The farther away a galaxy is, the faster it appears to be receding. This became known as Hubble's law. It's as if we are living on the surface of a balloon that is being inflated, with galaxies the dots on the surface of the balloon. As the balloon expands, the dots get farther apart. This isn't the galaxies moving through space, but the space between them growing larger. But this expanding universe is not simply a fact of the past. It is happening right now, in real time. The universe is constantly stretching, pushing galaxies and cosmic structures farther apart. Yet, there's more, a deeper layer to this phenomenon that astronomers would discover just decades ago. In the late 1990s, scientists made a discovery that sent shockwaves through the scientific community. Not only is the universe expanding, but the expansion is accelerating. Galaxies are moving away from each other faster and faster. What could be causing this? The answer, though elusive, would be one of the greatest mysteries of modern science: dark energy. Dark energy is a force or energy that permeates all of space and drives the accelerated expansion of the universe. It is estimated to make up around 68% of the total energy in the universe, and yet we know almost nothing about it. We cannot see it, detect it directly, or even measure it in traditional ways. Yet, we see its effects. It is pulling the galaxies apart, and as it does, it is altering the very fate of the cosmos. Imagine a force so subtle, so pervasive, that it alters the course of the entire universe, yet remains hidden from our direct observation. Dark energy has been described as a kind of negative pressure, a force that pushes outward, contrary to the attractive force of gravity. While gravity tries to pull matter together, dark energy accelerates the stretching of space itself. And its power is growing. It's mind-boggling, isn't it? A universe filled with galaxies, stars, planets, all moving apart, driven by an unseen hand. If dark energy continues to increase in strength, it will eventually pull everything apart. Galaxies, clusters of galaxies, even the very atoms that make up matter. We might find ourselves in a universe so spread out, so cold, that stars will burn out, galaxies will fade from view, and the night sky will become a distant memory. In billions of years, the universe will have evolved into a very different place. The stars we see today, shining brightly, will have burned out. The galaxies we admire, filled with clusters of stars and nebulae, will drift so far apart that they'll be invisible to us. Their light will no longer reach us. The night sky will become a void, a canvas of darkness with only the faintest echoes of a distant, more connected past. This is known as the heat death of the universe, where, after all the stars have died and galaxies are too distant to see, the universe will be in a state of maximum entropy. It will be a cold, dark place where energy is spread thinly and uniformly. No processes will be able to happen, and time, as we understand it, will grind to a halt. No new stars will be born. The universe will be a place of endless stillness. But what if this is not the end? What if there are other possibilities, other futures we haven't yet uncovered? Another possibility is that the universe could reverse its expansion, eventually slowing down and contracting, drawing everything back toward a single point. This is the idea of the Big Crunch, a collapse of space-time that would bring all galaxies, stars, and matter back together. If dark energy weakens or changes over time, gravity could win, pulling everything inward. Perhaps, after billions of years of expansion, the universe will fold back in on itself, creating a new singularity. Could this lead to another Big Bang? A new cycle of expansion? Some theorists believe the universe might go through cycles of creation and destruction, an eternal process of rebirth as old universes give birth to new ones. These are the great questions that fuel our curiosity. As we peer into the vastness of space, we are not just looking outward. We are also looking inward, questioning our place in the universe. Will we ever be able to fully understand the forces that shape the cosmos? Can we unlock the mysteries of dark energy and see a future where we continue to explore, grow, and understand? In the grand scheme of things, our existence is but a fleeting moment, a brief flicker in the eternal timeline of the universe. Yet, this very moment, the fact that we can ponder such grand questions, reminds us of the incredible journey we are part of. We are the eyes through which the universe is watching itself, the beings who stand at the threshold of discovery. And as long as we continue to ask, to wonder, and to explore, the journey of the universe will continue to unfold, an adventure that transcends the limits of time and space itself. The universe is expanding, It always has been, and it always will. Where it leads, we do not know. But in that unknown lies the beauty of exploration and the promise of discovery. As we stand at the edge of the cosmos, we can only gaze upward and wonder, what's next?